So guys, the demonstration's in the corner, so you might want to orient yourself towards seeing what's over there.
The video camera will be moving over there, so you will be able to see it on the screen, but sometimes it's
And good afternoon. Good afternoon, everybody. I'm Harold Giddish. I am the past president of the SAIA, but back in my day it was the SIA. From 2002 through 2004, those were the dark ages. Currently serving as your Region 9 Board of Director and Chair of the Suspended Scaffold Council. I now have the pleasure of introducing a dynamic duo for a live demonstration that beats a dead one. Please welcome Brian Andrew, Vice President of Engineering at B Access, and Bobby Zeolla, Vice President of American Anchor. Together they will be presenting a live demonstration of various anchor types under load. Their expertise in anchorage systems and member safety resources is unparalleled. Please give them a warm round of applause.
Thank you. How's it going, everybody? My name is Bobby Zeolla. As he said, I'm the Vice President of American Anchor. I've been in the fall protection industry working with anchor points for about 15 years. Started before college, went to college for business, came back and been working there full time ever since. Today we're going to be doing a live demonstration of pulling these anchor points. So as we go through, you'll see how different anchor points perform under different loads. So starting off, just a general overview of what anchor points are. Fall protection anchor points are one of the most critical components of fall protection systems. They serve as the actual attachment point to the building structure for your lifelines, tiebacks for outriggers, ends for horizontal lifelines, and equipment like that. They're in place pretty obviously to protect workers from falling. That's going to protect from fatalities and injury. All these anchors are only as strong as the structure you're installing them to. So when you're installing these anchors, you got to make sure that what you're putting them onto can support the loads as well as the anchor supporting the loads. That might be contacting a fall protection expert or an engineer that can actually look at the structure and make sure that it's adequate. Some of these systems, as we go through, keep in mind that they need to be engineered or designed and installed under the supervision of a qualified person. So that's pretty important there as well. Selecting the right anchor type is crucial to the task that you're doing. You don't want to, and we'll go through kind of some of the names of these fall protection systems, but you don't want to be installing, let's say, a fall restraint system in a fall arrest application, but we'll learn about more about that in a minute. We like to categorize these systems under three general systems, if you will. First one's going to be fall arrest anchor points. Next is suspended access anchor points. And the last one is designated fall restraint anchor points. So fall arrest anchor points are pretty popular. I'm sure if you guys are in the industry and have been on roofs, you've seen these things in the field. They're basically designed to stop a worker's fall after it has already occurred. So they're typically designed for 5,000 pounds per worker attached. And yeah, they're there basically to stop that person's momentum before they hit whatever's underneath. So keep in mind that it might not necessarily be the ground that you're trying to stop this worker from. It could be pipes or any other ledge or obstruction underneath them. So that photo on the left is what I call a sacrificial post anchor. So that's actually when it is arresting a fall, it's actually going to be deployed, and it's going to reduce the shock load on the structure that it's attached to, the anchor point, but also the person who took that fall, bringing them to a stop gradually. The anchor system to the right can be confused a lot with a fall restraint system, but in this situation, it is a fall arrest system because of how close that fall hazard is to the anchor points. And we'll talk about more of that in a second. Suspended access anchor points are any anchor points that are being utilized to go over the edge of the building. So that can be rope descent systems, popular, used for window cleaning or even some inspection work or repointing bricks, maybe glazing windows, stuff like that. And also tiebacks for your ballasted outriggers. So all those ballasted outriggers are getting tied back to a suspended access anchor point. And also, when you're on a suspended scaffold, the safety line also needs to be tied back to an independent anchor point. They can't share the same anchor point. These anchor points are designed and engineered to withstand 5,000 pounds in any direction. And again, the structure in these is very important to make sure that that structure can hold in any direction, not just the direction of use. Designated fall restraint anchors. These anchors are, it's important to know that you're working with a designated fall restraint system before you utilize the anchors, because these anchors are actually designed to a lesser load than some of the fall arrest and suspended access anchors. So you don't want to be putting these in a scenario that can actually, a fall can occur. Their main purpose is to limit the range of motion so the worker can't actually access that fall. So if we have an anchor point that's 10 feet off the edge, you only want to supply your worker with a 5-foot lanyard so he can't actually get to that fall hazard. We got a couple different anchor styles that we're going to talk about today. First one, I'm sure you guys all have seen, roof anchors. Then we're going to go on to wall anchors. Next is horizontal lifelines. This is often abbreviated with HLL. So if you hear someone in the industry say HLL, they're talking about a horizontal lifeline, and we'll look into that. Portable anchors, these are like those weighted carts you might see a lot. They're super popular in the roofing industry. They can be moved around, and they basically rely on friction to stay in place. That's that middle photo there. Trolley anchors, which are also referred to as monorail systems. Actually, a good example of this is in the hotel across the street at the Omni. If you're going up the elevators, take a walk to the window and look up, and there's actually a monorail system above your head. So that's a good example of a monorail there. And chokers and tie-off straps, super popular in the construction industry. All right, so roof anchors, again, I'm sure you guys have seen these if you've been working on roofs. They typically can be installed into concrete, wood, or steel applications. One thing to keep in mind with these is if they are installed into the roof, you don't actually know how tall that anchor is. So during testing and stuff like that, there could be a lot more leverage that meets the eye, basically. Could be a lot more post underneath that roofing insulation. So keep that in mind. So just to go through this a little bit, I'm going to ask for a show of hands of what we think that these anchors can be used for. So those systems we just went over, we have fall restraint, we have suspended access, and we have fall arrest systems. So with a show of hands, who thinks that they would be good for fall arrest applications, these roof anchors? Anybody? We got one. One, two? We got two? All right. We're getting there. Yeah, so these roof anchors are going to be, in most cases, good for fall arrest applications. How about suspended access work? Show of hands. Okay, a couple. Yeah. So most
now
of
we're
the
getting
time,
some more people.
Yeah. So most of the time, yes, roof anchors can be used for suspended access work. You do need to check the certifications on that. Those anchors do need to be load tested and certified, so that documentation needs to be up to date before you use them. Also, a thing to keep in mind is that photo on the right there. That is technically a roof anchor, but is not okay for suspended access work. So you really got to, again, make sure you know the system that you're dealing with, especially before using it for suspended access work. And again, that includes tiebacks for your ballasted outriggers and your independent safety lines on suspended scaffolds. How about fall restraint systems? This one's an easy one. Yeah, all these anchors can be used in fall restraint applications. Again, they hold a lower load rating, so you're pretty safe using most anchor points for fall restraint applications. I always say if you don't know what the anchor point is, treat it as a fall restraint anchor. That way there's no chance you're actually going to load that anchor point. Next up, we have wall anchors. Very similar, still have, for the most part, 5,000 pound load ratings. Again, getting installed into steel, exposed concrete, stuff like that. A good benefit to wall anchors versus roof anchors is there's no roof penetrations when you're installing these. That's going to save the client some money, and also, it's also easy to kind of verify that structure because it's right there in front of your face. You know it's in good condition. We install these on concrete walls, steel dunnage, and stuff like that. Okay, so I guess a show of hands again for fall arrest systems. Yep, fall arrest systems is super popular for wall anchors. Again, most of these are going to be holding that 5,000 pound load rating. Suspended access. Suspended access for the most part. Again, make sure that when you're using them for suspended access that you check in the systems documentation, make sure that they've been load tested and everything's compliant there. And fall restraint. Fall restraint, again, kind of a no-brainer there. What else we got? All right, so horizontal lifelines, another super popular form of fall protection. The big benefit to these is that you can actually span these over long distances, so you don't need an anchor point, every 5 feet to cover that swing radius. You can actually walk these systems and cover a large distance. Another good benefit to these is when you can get them to be a hands-free system. A hands-free system basically has a runner that clips on a cable, and you can walk past those intermediate anchors without having to unclip. If you didn't have that, you would need a double lanyard, come up to your intermediate anchor, unclip, clip on the other side, unclip your other lanyard, and then you can keep walking. A challenge with that is if the system's not easily usable, sometimes people just don't use it at all. So it's really important to design a system that's easy for the user to use to make sure that they're actually using them. These styles of systems do need to be installed and designed under the supervision of a qualified person, so that's something to keep in mind. So for fall arrest applications, how do you guys think that we can use those for these? Yes. So fall arrest applications are super popular for horizontal lifelines. How about for suspended access work or tying your ballasted outriggers back to independent safety lines, stuff like that? Anybody think it's okay for that? Pretty good. Yeah, no. So we don't want to. I'm hitting the laser. We do not want to be using it for that. They're not designed for that. There are systems such as that photo on the top right that if there's an anchor point that's rated for suspended access work, you can tie back directly to that anchor point, but we want to avoid tying directly to that cable. The cable's just there to walk that fall hazard and get to your work site. Fall restraint. Fall restraint's a super popular horizontal lifeline application. Cool. Brian's up.
Well, thank you. All right, so portable. Bobby had mentioned a little bit on portable temporary outriggers. So these are not permanently attached to the structure. These are held in place on the structure with either weights or a claw or a clamp that actually grabs the structure or kind of secures it to the structure. Some of these, because of that, come with a little bit of risk due to a little bit reduced friction. So if you can imagine putting a claw type system on concrete, it's not going to dig into the concrete. So you have to be a little bit cautious on that and where you're using that type of anchor. So based on this, for weighted or claw type portable anchors, fall arrest anchor systems, who do you think it can work with that? We've got a few. That is correct. How about suspended access anchors? Anybody on that one? No. Why? Portable, friction-based, not in any direction. Okay, that's the one main thing. It's not used in any direction. Oh, I went one too much.
Cheating.
Nobody saw that. Fall restraint anchors. There we go. We got a few right there. So yes, you can use these type of systems as a fall restraint. Now let's bring it over to a clamp type system. What about a fall arrest? Would these be approved for fall arrest? I see a lot of nods and hands. That is correct. How about a suspended access system? We got a couple. Yes, it depends, right? So yes and no. It depends on that anchor and that structure that we're actually attaching to. How about a fall restraint system? Yes. Now, I've actually been asked, how about putting a horizontal lifeline onto a clamp type anchor? No, you cannot do that because it's pulling the actual clamp at a different angle. It's not coming downwards, okay? So trolley anchors. So Bobby kind of hit on it with horizontal lifelines. They're very similar, but usually these are overhead. You have, once again, your ability to go and travel the full length horizontally along that beam or whatever we're attaching to. Common applications are on bridges, on the top of buildings, inside of buildings, you name it, for that type of a system. So fall arrest, are these typically used for fall arrest? Yes, they are. How about suspended access? Yes, they are. And last but not least, fall restraint. Yes. Okay, so once again, as we're seeing a lot of these types of anchors, some are used, some are okay. You really have to look at the type of the anchor, the application of the anchor. That is what this presentation is all about, and where we're really going to be explaining pretty soon. Choker type. So this is when you're actually wrapping a beam or you're wrapping part of the structure with either a wire rope or a cable or something like that to actually prevent and hold the structure. These, a lot of times, if it's wire rope, you have a rubber membrane around that rubber. So it's protecting A, the structure, but B, the actual wire rope itself. So these are usually, once again, made of synthetic webbing, wire rope. Sometimes I see them in chain, you name it. So are these typically used for fall arrest? Yes, they are. Suspended access work? Yes, they are. And fall restraint? You got it. So now the main reason why we're here. So a lot of anchors are needing to be tested after they're installed, okay? But not all. Not all anchors need that. So once again, the type of the anchor, the application of that anchor is really key on if it's needing to be tested after installation. So always consult with the manufacturer of that anchor to see what is actually needed for installation, for testing, for inspection of that anchor afterwards. So we're going to actually come on over here and have some fun now. And I do have to make a shout out to Becky, so thank you very much. I'm going to stand over here and continue talking while Bobby and Becky go and...
Safety first.
Yeah.
Becky did not like my hard hat.
So the first type of actual test that we're going to be doing is simulating a horizontal lifeline. Okay, so as you see right here, we're actually going to go and we have a wire rope that just goes between two anchors. And we're going to pull on that wire rope with a chain winch and register what the actual load is being applied to the anchors, all the different anchors on here, okay?
You guys are in the splash zone.
I don't know. Brian just told me to wear my hat.
What kind of load cell is that?
What
This-
kind of load cell? It's a dynamometer, so it's actually just telling you the actual pounds being applied. So Bobby's going to actually put about 1,000 pounds on this anchor right here. And then we're going to see what that registers over onto these other 2 anchors on the side.
600. 700. 800. Yeah, you're at 1,004. 5.
So what's that registered at, Bobby?
So we're at 1,050.
1,050. Over here, we are at 3,000 pounds.
And you can also notice that there is a little bit of sag in this cable. So if this cable was with a turnbuckle and it was even more taut than we could get it with no turnbuckle, that load would be even higher than that.
So this is why you cannot do this, okay? We see this all the time. And this is exactly why you cannot attach to this type of a system, okay? Once again, 1,000 pounds over here, 3,000 pounds over here. So it's triple the amount of load. It's crazy. All right. So now what we're going to actually be doing is we're going to release the load here, and then we're going to pull between these 2 types of anchors. And these 2 types of anchors are your suspended access type of anchors. Okay? So first what we're going to do is remove the load. We're going to remove this wire rope in between. Then we're going to put the chain winch between these 2.
I think we're gonna remove this cable right off of here.
Can you pull that?
Where's your hard hat?
I'm over there. Nobody sees me.
Yeah, let's take that whole thing off. We're done with that load cell and everything.
Nope.
So another thing to keep in mind with those horizontal lifelines is that's why a lot of them are going to have some sort of energy absorber built in. So the lifeline can be taut, but if a fall was to occur, it's going to add that sag into the cable, which is going to reduce the loads on the end anchors.
Hey, Bobby, can you grab the angle over there?
Yep. Excuse me.
So what we're actually also going to do is we're going to show what these different types of anchors do under load, okay?
Yeah.
Before and after
Probably
the
both.
anchor is under load. So the number one thing is seeing if it actually bends, if it yields, okay? So what we're actually putting on right now that Becky's got is an angle and registering that both of those are straight up and down, right, Becky? Yep. She said yes, in case anybody didn't hear.
So we're going to load these up to the full 5,000 pounds to make sure that there's no deflection in these posts, and if there is a slight deflection, that it's elastic and returning back. So you'll see that this load's going to spike up a lot faster than when we pull on the cable because of that cable stretch.
Yeah, like about,
What do you want to go to?
oh,
We're going to go to 5K. Yep.
yeah, so like Bobby's saying,
So we're already at 3,000 pounds with just a couple clicks here.
this goes extremely fast because these are built and these are designed to take the load and not bend, not yield very much, very quickly at all.
We're at 4,500 pounds. 47,
There you go. You're just over.
5,000, 10.
So 5,000
There's also
pounds.
probably a little bit, it might fall off. There's a little bit of deflection in the structure with these aluminum beams. Yep.
So you're off a little bit.
So we can see a teeny bit of deflection, but nothing to be worried about there.
No.
And none there. Perfect. So then when we release, you can actually, a lot of times you'll see these anchors spring back. And it's not necessarily the anchor point that's deflecting. Again, it's more that structure. Even on steel I-beams, they have a little bit of flexibility in it. But as long as when we let these off that the angle is back and it's squared up is good. So we can let this off now. You also want to make sure that it's holding the load and those numbers aren't dropping drastically as the load sits on it. All right.
What we're actually showing for the load of 5,000 is what the anchor can actually
We actually
handle.
got to switching around.
Okay.
Because that's going to deploy, so I just want this.
We're not actually load testing an anchor right now. What we're actually showing is the full capacity of those anchors. Okay. So what those anchors are truly designed for.
So. Yep. So back to this one. Sorry, Ricky.
All right. So now actually, so usually what you're also doing is you're checking the anchor after it's been load tested. Okay. So right here we are perfect, 90 degrees. And then the same thing over here. Let's just check that one just to make sure nothing happened there. Nothing happened. So those two anchors, as you see, are approved for use for suspended access. There is no deformation, there's no yield, they can handle 5,000 pounds. Okay. Now what we're actually going to be doing, hey Bobby, hold on one sec, is we're actually going to be pulling between a suspended access anchor and a fall arrest anchor. Okay. Now let's see what this anchor does.
I've never actually done this, so I'm taking Brian's word for it that we're all safe over here. So already we're at 220 pounds.
220
right
pounds,
now, and
and something's
it's
already
yielding.
bending over there.
So it's probably not going to get much higher than 220 pounds. Another thing to keep in mind if you're using this style anchor that can be used with a horizontal lifeline, if anybody comes over and loads that horizontal lifeline with their foot or they sit on the cable, it's going to produce over 200 and something pounds, and it's going to damage these anchors, especially the end units.
And Bobby, you can just keep going. You cannot reuse that anchor, as you'll be able to see. And where are we at?
We're actually at 1,000 pounds right now, but it should start to deploy.
There you go.
I think
So
that's
that's good right there, Bobby.
What's that?
So that's good. So pretty much what you're doing is you see what this does is this anchor is designed to take a load, take a drop load very quickly. It goes and expands and still holds the load and the person from falling. And yeah, I don't think that's 90 degrees anymore.
Definitely not.
Okay.
So now we can pull that one off.
So if we were to shock load that more, as seen in some of those photos, there's actually like a coiled spring that will deploy out probably like this far, but we'd just be cranking that and cranking it and cranking it, and it would just be kind of anticlimactic because it's going to happen kind of slow. But in a fall arrest application, that would happen kind of fast.
Yeah, you're gonna. Cool. And I'll throw the 90 degree on this anchor just to make sure that nothing happened here. And we are all good.
You can go to the shackle or that, whatever one you want. Yeah, I guess to the shackle.
Shackle's usually easier, yeah. So yeah, sorry. So for this one, we're actually going to show the angle prior to loading. What? Okay. Yes.
Can that anchor that's been deformed, can that be replaced without demolishing around it?
That's going to depend on the manufacturer, on the building engineer to confirm that after that's been loaded, that can still support a load in that same area. Usually, you're not going to use the same holes. You're going to put in different hole pattern in a different location in the same area, but not using the same holes. Okay?
Yep.
Oh, I'm sorry, I didn't. Yeah.
Yeah, most of the time, they're going to just say to replace the whole thing. We've seen these damaged by ice loads, snow loads, everything in New England quite a bit, and they're just like, you need to reuse a whole new location. Another benefit to installing a rigid post that's probably not going to be affected by snow loads.
All right, so this one, we're going to go from a suspended access anchor to another fall protection anchor.
Sure, at the top. It's always good to test these at the top of the U-bars here. That's going to be the anchor's weakest spot, nice and high.
Look at the worst case.
Yep. We're at 700 pounds right here. 1,300. And again, our target for anything rope access is 5,000 pounds, 1,900. How are we looking over there? 23.
Brian, move the phone go.
It's 25. 3,000. Come over here, get a little more leverage. How are we looking? We're at 32. Is it bending already? Yeah. Yeah, you can see too, the mast is bending, but also this plate's lifting. In an application on their website, they do say to utilize more holes than what we're utilizing here, but we found in shop testing that it still lifts that plate. Something to keep an eye on too. But let's keep going. It might not get any higher than this. We're at about 37. Yeah, I think it's just gonna keep bending. The more I crank, the more it's gonna bend.
It actually does go up to 5,000 pounds, but let's pull it off and let's see if this stays in position.
Let's see, what's that angle?
And goes back to 90 degrees. Anybody think it will?
I don't think we need to put this on here right now, but, but we're not doing too good over here. And again, you can see that big bow in the plate. So we'll release it, see how we do.
So once again, the main point here is not saying certain anchors are superior to other anchors. The point of this presentation is to explain that there are different types of anchors for different applications. All these anchors are perfectly fine for their designated type of systems. Okay? And if we put the angle on this one,
Oh yeah, it's still super bent. Yeah.
permanently bent.
And the blade load tested the other way, bend it back.
Yeah, just load test it the other way per Harold and just bend it right back. We're all good.
So what happens a lot in the industry is we'll be called out to, there'll be a GC who installed 100 of these. We'll be called out to load test them, certify them for fall arrest and or suspended access work, and we don't even bother testing them because we know this is how that they perform. So that's always a difficult conversation with the client at that point. So it's good to do your due diligence before installing these.
Yep, so once again, as we said right at the beginning, always consult the manufacturer. Okay?
And you can see
what type of anchors need to be load tested to what load capacity they can be tested to, you name it. Always consult the manufacturer prior to load testing an anchor.
And you can see, obviously, we've done these tests in the shop before bringing the rig here. All these other anchors here were load tested to 5,000 pounds many times, and they'll hold it over and over again.
All right, so based on what you all saw, any questions? I'm expecting a bunch.
When they're installed,
Gary, we will pick up on the audio.
When the anchors are installed initially and say certified, there's supposed to be paperwork with the building engineer that's left there for whichever anchors do have to be certified annually?
That is correct. And actually, can you put the PowerPoint back on?
So it's also the building's responsibility to provide that documentation to you guys. So when you guys get there, it's their responsibility to provide a safe workplace for the tasks that you guys are doing.
We can go back up top.
Yeah.
Sean.
Are all fall arrest anchors rated with a 5,000-pound capacity?
No. Not all of them are rated solely for 5,000 pounds.
And so in which case it would then be an engineered system with a safety factor of 2.
That is correct.
And the only way to determine that is to, of course, consult the manufacturer.
I'll insult the manufacturer. Exactly why we're always going back to the same exact thing. I already knew exactly where Sean was going there.
But the answer is yes with suspended access anchor points.
Yes. Any other questions?
Thanks, Jackie.
Jackie's getting her workout
Yep,
today.
let's go. Send her back.
What are the guidelines of what the anchors should be load tested to?
We are actually not going to answer that question. Okay? We're going to answer that question in about 2 years.
There's basically a lot of nuances in the codes, and it can be debated a couple different ways.
Yeah. Consult the manufacturer. That's the best way. Okay? They're going to tell you what they recommend to load test their own anchors to.
Mm-hmm. And again, as you can see, for the most part, with that load testing, it's not the anchor that's going to be the weak point. It's the structure you're mounting it to. So.
Any other questions? Well, one final thing I want to say is thank you very much to American Anchor, B-Access, and Sky Climber for all donating some anchors for this presentation. And then last but not least, we wanted to say this reception is right outside here at 6 o'clock today, and the gala is inside here at 7 o'clock. So thank you all very much. And if you have any questions, please feel free to come on up and speak with Bobby or myself with any other questions that you didn't want to go and broadcast amongst everybody.
Thank you, everybody. Appreciate it.
Thank you.